Okay, good day everyone. Maulang araw sa inyong lahat. Talagang ngayong week na to, masyadong maulan. So, pasensya sa background na maulan. Yun, okay. For today, ang ating topic is, ito-discuss ay ang kinematics. Okay, so next slide. So before we start, mag-ano lang tayo, balikan na natin yung some physics quantities. So under here, itatakal natin yung vector and scalar. So what is vector? A vector is a quantity with both magnitude and direction. And then a scalar is a quantity with magnitude only, so wala siyang direction. So here naman, yung mga samples or sample quantity na under sa vector and scalar. So sa vector, under sa kanya ang displacement, velocity, acceleration, momentum, and force. And for the scalar, nandito ang distance, speed, time, mass, and energy. Okay. So next, i-differentiate natin ano ang difference ng mass at saka ng weight. So what is mass? Mass is a scalar quantity. So wala siyang direction. It only has magnitude. And the mass is, it measures the amount of matter in an object. And then ang weight naman is a vector quantity. Meron siyang magnitude and direction. And yung direction niya, it points towards the center of the earth. And ang weight is a force of gravity of an object. Since yung weight natin, ang formula niyan is mass times gravity. So here, may example lang tayo dito para mas ma-visualize niyo ano ang difference ng mass and at saka ng weight. So example, you are on the moon. Your mass would be the same, but yung magnitude ng weight mo would be less. Nagadepende kasi yung ating weight sa gravity. So, yung gravity na 9.81 meter per second squared is exclusive lamang yan sa Earth. So, depende what planet are you on, kung anong gravity meron doon. So, dun mag-vary ang weight. So, ang may variation ang weight, ang mass is constant yan siya kung ano ang mass ng isang object. So, next is vector. So, yung vector, paano tayo mag-present ng vector na handwritten? Okay, vector are represented with arrows. The length of the arrow represent the magnitude. So, kung mas malaki yung arrow, yung length ng ating arrow, doon nagre-represent kung how far, how fast, how strong, at saka depending on the type of vector. The next is yung arrow points in the direction of force, motion, displacement, and etc. It is often specified with an angle. So, example nito is ito. So, here is our vector. Meron tayong magnitude and then ang kanyang direction. Okay, next. So, balikan lang din ulit natin at itong mga units natin, ha? Since na-topic na natin ito siya sa prelim. And then, itong mga matakal natin dito is itong mga standard quantity and unit symbol nila. So, meron tayong quantity nasa left side kumbaga, and then yung unit and symbol natin is itong mga nasa right side. Okay, we have a quantity ng displacement and distance. Meron silang unit and symbol na meter at saka m. Okay, so next, time, second, and then symbol na letter S, small letter s. Velocity and speed, meron silang unit na meter per second. Acceleration, meter per second squared. Mass, kilogram, kg, ang kanyang symbol. Momentum, kilogram meters per second. Force, Newton, at saka ang symbol niya is big letter M. big letter N. And then lastly, energy. Ang kanyang unit is joule, and then ang symbol is big letter J. Okay? So, since natapos na tayo sa pag-recap, introduction na tayo sa kinematics. So, what is kinematics? Under siya sa dynamics. At saka ang dynamics is a branch of mechanics which deals with the motion of the bodies, under the action of forces. A body is said to be at rest if it does not change its place or position with respect to its surroundings. No body on this earth is at absolute rest. Kasi yung ating earth, nag-rotate siya sa kanyang axis, and then nag-rotate din tayo sa sun. So, yun nga, nobody is in this earth is at absolute rest because they are sharing the motion of the earth. A body can be at rest with respect lamang to another body. So, parang meron tayong reference, point of reference nito, or frame of reference. So, a body is said to be in motion if it changes its place or position with respect to its surrounding. Example nito, a person in the moving train feels the motion, seeing the passing objects through the windows. Hence, rest and motion are relative terms. The motion of the body is characterized by two quantities. Ito yung ating force and momentum. If a body is in motion with acceleration, then the body is acted upon by a force. Force equals to mass times acceleration. Ito yung ating F equals to ma. If a body is in motion with uniform velocity, there is no acceleration. Then the motion of the body is only under the momentum, yung ating mass times velocity. Okay, next. So, summary lang natin yung ating kinematics. Kinematics, we describe motion in terms of space and time while ignoring the agents that cause that motion. This portion of classical mechanics is called kinematics. Yun nga. So in kinematics, studies motion without thinking about its cause. And then under kinematics, isang mga important factor nito is yung position. The location where something is relative to a coordinate system is called a frame of reference or point of reference natin. Position is relative to a reference frame. Example nito, nasa Earth tayo. So Earth is the most common reference frame, but it could be something else. Most common coordinate system is yung ating X and Y coordinate system. Okay, next. So, recap lang natin. Another brief kinematic definition. So, kinematics is a branch of physics that study motion. And then yung ating position, which is denoted na small letter X, it specifies where you are located. And then yung distance denoted as a small letter D, which specify how far you have traveled regardless of the direction. And then lastly, displacement, denoted as delta X, which specify where you are in relation to where you started. Okay, next slide. Pag-usapan natin anong pinagkaibahan or what is the difference between the distance and displacement. So yung distance, ito yung total length of path taken or yung total distance travel natin. Yun nga, length, since distance yung pinag-usapan natin. So, yung distance is a scalar quantity which has a magnitude only. And then yung displacement naman natin, ito siya yung change in position relative to a reference frame. Ang kanyang formula is yung ating delta X is equals to the final position minus nung sa initial position. And then ang displacement, again, is a vector quantity. It has direction and magnitude. And then sa displacement, it does not particular or path does not matter in displacement. It only depends on the final and initial position. Yung displacement is the shorter length or path from the initial to final position. Okay? So, dito, ma-visualize ninyo ano ang pinagkaibahan ng ating distance versus displacement. So, example, you drive the path and your odometer goes up by 8 miles. Ito yung distance mo. So, ito yung total distance traveled mo. Pero yung displacement is the shorter directed distance from the stop start to stop. So, ito yung ating start and then ito yung ating stop. So, ito yung red, ito yung ating distance, ito yung total length na gi-travel mo or ng path natin. Okay? And then, ang ating magnitude, ang ating displacement is itong green arrow natin, which is the shorter directed distance from the start to stop. So, from initial position natin to final position. So, yan ang malaking pinagkaibahan ng distance sa displacement. Okay, next. Meron tayo ditong sample problem regarding sa ating displacement. So, example dito, you have drive 20 km east. So, sandali lang. So, i-ano natin ha. Ito na pala. So, meron tayo ditong one-line diagram. So, you have drive 20 km east, then turn around and drive 15 km west. What is your displacement? So, yung ating 20 km, ito yung ating color blue na arrow. Okay? So, itong ating 15 km is itong ating color green na arrow. So, makikita nyo sa ating one-line diagram na from 0 to 20, ang travel mo from east. And then from that point, bumalik ka at nag-travel ng 15 km west. So, makikita mo agad dito kung ano yung displacement mo. So, 5 km west. Papunta siya ng west. Papunta siya ng east. Okay. Pero kung ipapasok natin siya sa ating formula na delta x equals to x minus 0. So, naging 5 minus 0. Dito na siya kuha ng reference point. Pero kung ito ating ipasok, kumbaga yung ating initial position is nasa 20 kilometers, so 20. So minus 15. So meron tayong negative 5. Pero sa direction na yon, ito ang ating basehan is yung mas malaki, which is papuntang east. Yung last direction natin papuntang west. So, negative 5 due west. So, para ma-positive natin siya, dapat yung ating statement is positive. So, magiging positive 5 or 5 kilometer. And then, di ba, negative 5 kilometer due west. So, magiging 5 kilometer due east of your starting point. So, ito yung ating statement, correct statement. So, next is what is your distance traveled? So, ito yung total distance total length na travel nung car. So, meron tayong first 20 kilometer, and then again, meron tayong 15 kilometers. So, total distance traveled is 35 kilometers. Okay, next, meron tayo dito another problem. So, what is the displacement of the path in the diagram? So, dito sa diagram natin, makikita mo, ang ating initial position is nasa negative 5. And then, ang ating final position is nasa 7. So, kung pasok natin siya sa delta x equals to x final minus x initial. So, meron tayong final natin is 7 minus, ito, negative 5. Okay, 7 minus negative 5. So, ito na siya. Meron tayong displacement na 12. Okay, so next. Tackle natin ang ating speed, velocity, and acceleration. So, yung ating speed is naka-denote siya or represented siya as small letter v. It specifies how fast you go. Yung velocity naman is represented din siya letter v pero makapal yung ating lettering or naka-bold, written bold siya. So, it specifies how fast and which way you go, and it is the rate at which the position changes. Yung average speed naman is denoted siya as letter V with bar sa taas. Ang kanyang definition is distance over time. And then, or total distance over yung ating delta t. So, acceleration naman represented as small letter A. It specifies how fast you speed up, slow down, or change direction. It is the rate at which the velocity changes. So next, sample lang tayo sa ating speed and velocity. So parang same lang din sila sa ating distance and displacement. Pero dito, itatakal natin ano ang kanilang difference. So ang speed is a scalar. It only has the magnitude and ipinapakita dito kung gaano kabilis, how fast something is moving regardless of its direction. So example ng ating speed is equals to 20 mph. So speed is a magnitude of velocity. So yung velocity is combination of speed and direction. So example nito, meron tayo again yung speed natin na 20 mph. Pero meron tayong direction na 15 degree south of west. So ito ang pinagkaibahan nila. So ang ating speed is yung ito lamang ang ating 20 mph and then or magnitude lamang, and then velocity meron na tayong direction. So yung ating symbol for speed is pares niya again sa ating velocity, so v. The symbol for velocity is typewritten kung naka-type or naka-word tayo, naka-bold siya na small letter v. Or kung handwritten, meron siyang arrow sa taas. Okay, next. So here, another continuation lang sa differences ng ating speed and velocity. Example, during your 8-mile trip, which took 15 minutes, your speedometer displays your instantaneous speed, which varies throughout the trip. So your average speed is 32 miles per hour. And then your average velocity naman is 32 miles per hour in southeast direction. So ang average speed natin, magnitude lang. Ang average velocity, meron siyang direction. So at any point in time, your velocity vector points tangent to your path. So example nito or representation nito is itong color green na arrow. So tangential ang kanyang path from your position or vector point. So example nito, ito ang ating vector point, meron tayong tangential path na representation ng ating velocity. And then, the faster you go, the longer your velocity vector is. So itong example or representation is itong red na arrow. So kung gaano kabilis ang iyong takbo or velocity is magre-represent dito. So i-represent siya like this kung gaano kahaba ang iyong arrow. Okay, next. So, next is yung acceleration natin. So, again, yung acceleration specify how fast you speed up, slow down, or change direction. It is the rate at which the velocity changes. Example nito ha, meron tayo dito dalawang example. So, here we have time at saka ating velocity. Ang time natin naka-second, velocity is mile per hour. So, at 0 second, meron tayong 55 mph. At 1 second, meron tayong 57 mph. At 2 second, meron tayong 59 mph. And at 3 second, meron tayong 61 mph. So, ano ang ating acceleration? So, di ba ang ating formula here is yung ating delta V over delta T. Okay? So, yung delta V natin is from velocity final minus velocity initial over, same lang din, over time final minus time initial. Okay? So, kung ganon, meron tayong, kuha lang tayo, ito ang example natin, ito lang. So, kuha lang tayo ng random points na magkasunod. So, meron tayong 57 minus 55 for delta V. So, meron tayong 2 mph. Diba? And then, over, yung delta T natin is 1 minus 0. So, meron tayong 1 second. So, meron tayo ng acceleration na 2 over 1 second o 2 mph. So, ito na. So, positive 2 mph per second dahil accelerating ang ating speeding up, kumbaga ang ating acceleration. Pataas siya. And then here, meron tayo, kumbaga, slowing down from higher acceleration, nag-slow down tayo. So, from time na 0 second, meron tayong 34 meter per second. At 1 second, meron tayong 31 meter per second. At 2 second, meron tayong 28 meter per second. And last, meron tayong 3 second, and ang kanyang velocity is 25 meter per second. So again, ito ang kunin natin ito. So ating delta V is 31 minus 34. Okay? So meron tayong negative 3. Okay? So 1 minus 0, meron tayong delta T na 1 second. So meron na tayong acceleration na negative 3 meter per second over second per second. So meron tayong negative 3 meter per second squared. Then next slide is yung rules for the sine of x velocity. So here, meron tayong x coordinate and here is yung ating x velocity. O yung ginamit kasi dito, yung ating direction is nasa x-axis, kaya naka-x lang siya. Okay. So here, meron tayong velocity positive papunta sa positive x direction. So, ang ating x-coordinate is positive, and then ang ating velocity is positive. Kumbaga, it moves towards the positive direction. And then, here, next case, from positive direction, yung ating velocity is papuntang negative direction. So, ang ating x-coordinate, positive nga, pero decreasing value kasi pabalik yung ating velocity. And then, ang ating velocity negatives since it moves toward the negative direction ng ating x-axis. And the next case is from negative x-axis, pero meron tayong positive velocity na papuntang positive direction ng x-axis. Ang ating x-coordinate, again, negative kagaling siya doon, pero increasing ang ating value dahil papunta ang ating velocity sa positive direction ng x-coordinate. So again, ang ating velocity is positive. So last case is from positive papunta sa negative, negative papunta palalo sa negative yung ating velocity. So negative ang ating x-coordinate at decreasing ating value dahil ang ating velocity is moving towards the negative direction palalo. Okay. So next, meron tayo ditong mga kinematics problem. Na-topic na natin ito last prelim, pero i-recap natin. So here, meron lang tayong gawa ko na siya na figure. So wala na yung ating word problem. So from the starting point, itong ating T1, T sub 1, meron tayong time na 1 second. And then sa ating final position, P sub 2, ang ating time is 4 seconds. So yung ating position from the initial point is 19 meters. And then ang final position is 277 meters. So yung ating delta x or yung ating displacement is x squared, x sub 2 minus x sub 1 or yung ating final position minus initial position. So meron tayong 277 minus 19. So meron tayong value na 258 meters. And then yung ating delta t is yung final is 4, initial is 1. So meron tayong 3 seconds. Okay? So with that, meron tayong average velocity. Ang ating formula is delta x or yung ating displacement over delta t. So meron tayong values sa displacement na 258 meters. And then yung ating delta t is 3 meters. 3 seconds. So meron tayong average velocity na 86 meter per second towards, asan siya papunta? Towards east. Okay. So next problem natin, same lang sila. Halos same lang sila, pero yung ating motion is papunta sa negative direction. Okay? So, yung ating point, initial point is nasa 277 meters. Ito yung ating initial position. And then, papunta siya sa 19 meters. And then, ang initial time natin is 16 seconds. Sorry. Okay. And then, yung final time natin is 25 seconds. Okay. So, ang delta t natin, yung final position natin nga, di ba, 19 minus 377. So, meron tayong negative 258 meters na displacement. And para sa ating delta t, yung ating final time is 25 minus 16, meron tayong 9 seconds. So, i-ano lang natin siya dito, i-substitute natin sa value, sa equation natin sa average velocity. So, meron tayong negative 258 meters over 9 seconds. So, i-calculate nyo yan, input sa calculator, may lalabas na value na negative 29 meter per second, papunta siya ng west. Okay. The next problem natin is find the displacement, average velocity, and average speed of the car in the figure between points A and F. So itong ating figure, so first is yung ating direction sa A to B. Papunta siya, kumbaga itong ating direction ha. Ito yung west, ito yung east. Okay. So yung A to B papuntang east, so meron tayong position na times, position A, ang time is 0 second. Ang position niya or displacement niya is 30, position lamang. Position niya is 30 meters. And then sa point B, at 10 seconds, nasa 52 meters na siya. And then after nung nakapunta na siya dito sa ating point B, is nag-ano na siya, nag-drive na towards west. Okay? So makita niyo dito, from there, nagbaba na ang kanyang value. Kung itong one-line diagram ang ating babasehan. Okay? So, sa point C, 20 seconds, nakadating na siya sa 38 meters pabalik. And then sa point D, 30 seconds, nasa point 0 na, sa 0 meters na siya na position. At nang sa point E na siya, at 40 seconds, negative 37 meters ang position. At nung last position niya or final position F, nasa 50 seconds, nasa negative 53 meters na siya. So, kukunin natin yung displacement. So, yung ating formula sa displacement is delta x equals to final position minus nung initial position. So, meron tayong final position na negative 53, di ba? And then, i-minus natin yung initial position natin na 30 meters. So, meron tayong delta x na negative 83 meters. Yan ang ating displacement, negative 83 meters due west. Due west. So, average velocity, ang formula natin is delta x over delta t. So, meron tayong delta x na negative 83. So, kukunin natin ang ating delta t. So, ano ang ating final time? Final time is 50 seconds, di ba? Minus 0. Okay? So, meron tayong average velocity na negative 1.66 meter per second. So, last, ang ating average speed. Ang formula ng ating average speed is yung ating distance over time. So, yung distance traveled ito ha. So, lahat-lahat na. So, from A to B plus B to F. Bakit siya nagka-separate? Dahil yung ating A to B motion or direction papuntang east, di ba? And then yung ating sa C to F na, papunta na siya ng west. Okay. So, A to B, i-plus lang natin 52 minus 30 plus 52 minus, 52 plus 53. And then yung ating delta t, which is from A to B, is 10 minus 0 plus, dito B to F na is 50 minus 10. So kaya meron siyang 40. So yung ating average speed, ito na. So 2.54 meter per second. So yan ang ating average speed. And then next topic natin is itong velocity and graphs. So in this lesson, we will explain the relationship between instantaneous velocity, average velocity, instantaneous speed, average speed, displacement, and time. And then we will also calculate the velocity and speed given sorry. So in this lesson, we will also calculate the velocity and speed given the initial position, initial time, final position, and final time. And then we will also derive the graph of velocity versus time given that of the graph of the position versus time. And then ma-interpret natin yung graph of velocity versus time. So again, yung ating velocity is a vector, di ba? It has direction. And sa kanyang formula is displacement over time. And then yung ating speed is scalar, wala siyang direction. Ang kanyang formula is distance over time. And then they are both, ang kanilang unit is meter per second. So here we have the position versus time graph. So itong displacement, ito yung ating position, and then ito yung ating time. So yung time natin, nasa x-axis ha, horizontal. So the slope of position versus time graph is the velocity. Diba? Kasi yung ating displacement over time, yung ating velocity. So velocity is rate of change of position. Yung ating formula for this is yung V bar over x final minus x initial. So in zero natin initial over t final minus t initial or delta x over delta t. And then yung ating formula para sa displacement is equals to velocity or v bar times t plus initial position or x sub 0. If the graph is not straight line, then use the slope of tangent line to draw the tangent line drawn to that point. So example nito, yung ito ating point P na nasa time 10 seconds. So yung sa point P, gagawa tayo dyan ng straight line to find the delta x niya at saka yung the delta t niya with respect sa point P or with respect to time na 10 seconds. And then same goes sa ating point Q. So gagawa ka para kung ang ating graph is naka-curve line siya and then may given point ka, maggagawa ka ng straight line or i-act mo siya ng straight line para makuha yung mga differences ng ating displacement and time. So here meron tayo dito sample problem. So the graph at the right shows the height of a ball thrown straight up versus time. Find the velocity of the ball at 2 seconds. So yung ating formula again para sa velocity is yung delta x over delta t. So yung delta x again is final velocity minus initial velocity. Final position minus initial position. Sorry ha. So yung x natin, displacement yan. So position lang kita pag-usapan. Over delta t na final time minus initial time. So nasa graph na din, napakita na yung ating position. So ito ang ating position again, di ba? So dito, ang ating final position, 4.2 cm. Ang initial position is 1.7 cm. Okay, substitute yung value na yon, and then dito sa time natin, final time is 3 seconds, and then initial time is 1 second. So again, i-substitute. So meron na tayong velocity na 1.3 cm per second. And then, last illustration para sa velocity and graph. Here, the spine-tailed swift is the fastest bird in powered flight. Excuse me, number. On one flight, a particular bird flies 306 meter due east and then turns around and flies 406.5 meters back west. This flight takes 15 seconds. What is the bird's average velocity? So, kukunin natin yung kanyang velocity. So, again, ang formula natin is delta x over delta t. So, nandito, ang gipasok niya dito is 306 minus 406.5 meters over 15 seconds kasi given naman ang ating delta t. And then, ang value natin is negative 6.7 meter per second. Asan siya papunta? Ito. So, since ang i-consider natin na positive is yung east. So, ang ating statement dito is negative 6.7 meter per second due east. Pero ang ating pag-statement dapat is positive. So, since ang value na negative 6.7 7 is nasa east, ang positive na value niya is nasa west. So ito yung tamang statement. So 6.7 meter per second west. And then next yung ating average speed. So yung ating average speed, ang formula is distance over time, or yung ating total distance traveled over the delta t. So yung ating total distance, again, 306 meters plus 406.5 meters over yung ating time na 15 seconds. So meron tayong average speed na 47.5 meter per second. And then lastly, which of this would we use to say how fast the bird is? So ang answer is gagamitin natin to define the speed or gaano kabilis yung ating bird is yung ating average speed. Okay? So next natin, yung ating acceleration and graph. So in this lesson, we will define and distinguish between instantaneous acceleration, average acceleration, and deceleration. We will calculate acceleration given yung ating initial time, initial velocity, final time, and final velocity. And then we will also determine the average or instantaneous acceleration from the graph of velocity versus time. And then lastly, we will derive a graph of acceleration versus time from the graph of the velocity versus time. Excuse me, wait lang. Okay. So next slide, meron tayo ditong representation ng ating acceleration. So acceleration, ito yung rate of change ng ating velocity. So yung ating acceleration denoted as letter A. For this sample, A bar is equals to delta V over delta T. Again, yung delta V natin is yung ating final velocity minus initial velocity over yung final time minus initial time. Okay. So, for this topic, since acceleration ang ating topic, ang ating velocity makukuha natin with the formula na acceleration times time plus yung ating initial velocity. Okay. So yung acceleration is a vector quantity. Yung unit niya is meter per second. And then if the acceleration is the same direction as the motion, then the object is increasing ang kanyang speed. If the acceleration is opposite direction sa motion, then the object is decreasing ang speed. So example nito, itong ating figure, okay? So letter A, yung ating velocity is the same ang motion niya sa ating acceleration. So from that, ang ating object is, or ating car is increasing ang speed or speeding up. And then dito sa ating letter B, ang ating velocity is towards the positive direction ng x-axis. And then yung ating acceleration is towards naman sa ating, or opposite direction ating velocity. So with this representation, yung ating acceleration is opposite sa direction ng ating motion. Then yung ating car is decreasing ang speed or slowing down. And then same lang siya dito sa ating letter C na representation or a figure. So here makita nyo na opposite ang ating velocity and acceleration sa kanilang direction. So slowing down ang ating object. So here sa letter D, same ang kanilang movement or ang kanilang motion or ang kanilang direction. So ang object natin is increasing ang speed or speeding up. Okay. So next, constant speed. Yung constant speed, constant acceleration. So yung constant acceleration, the graph of position time is parabolic. So ito yung ating representation. Itong upper figure. So kung ating position time is parabolic, ang ating formula para sa displacement or ang ating x is 1/2 AT squared plus v sub o or yung initial velocity times time plus initial position, which is quadratic. And then, if the time graph, yung ating graph of velocity time is linear or straight line, yung ating formula para sa speed, para ating velocity is AT or acceleration times time plus initial velocity, which is linear. Kaya straight line. Okay. So next, meron tayo ditong illustration para sa ating acceleration and graph presentation. So here we have a sample illustration. A dropped object near the earth will accelerate downward at 9.8 meter per second squared. Ang gagamit tayo ng negative 9.8 meter per second. Bakit? Kasi downward ang ating acceleration. Nagsabi siya dito na downward. So yung downward is towards the negative y-axis. Ayaw lagi nito. Wait lang. So, if the initial velocity is 1 meter per second downward, what will be its velocity at the end of 3 seconds? Is it speeding up or slowing down? So, yung ating acceleration, ang kanyang formula again is yung ating delta v or yung ating change of velocity over change of time. Okay, delta t. So, final velocity minus initial velocity over final time minus initial time. So, lang natin ha, substitute natin yung mga values since ang ating acceleration given, ang ating acceleration is negative 9.8 meter per second squared. Bakit? Dahil dito sa word na to, downward. So, kumbaga, x-axis natin, downward siya towards negative value. So, okay, negative 9.8 meter per second squared equals to, hahanapin natin ang kanyang final velocity. Since given ang initial velocity, ang hinahanap is ang final. So, v sub f, ang ating variable, minus negative 1 meter per second. Bakit negative 1? Dahil naman, again, sa ating word na downward. Okay? Over ang ating time na 3 seconds. So, we have final velocity na 30.4 meter per second downward. Okay. Since negative ang kanyang value here, so ang kanyang statement is downward. Okay? So next. Next natin is itatakal natin yung mga equation for the one-dimensional motion with constant acceleration. The straight line motion, kumbaga. Assumption dito, we assume that yung ating t sub o or yung initial time natin is 0. So, yung ating delta t is equal dun sa final time na t na lamang. Depende kung ano ang given na final time. And acceleration is constant. So, yung ating average velocity is equals to delta x over delta t. Tama. Delta t, pero yung ating delta t, di ba, is t na or time na. So, we have here na yung x natin is equals to average velocity times time plus yung initial position. And another pa, yung ating average velocity is, another formula niyan is yung i-plus mo yung dalawang velocity, yung initial plus yung final velocity. And then yung average nila, so i-divide mo sa 2. So itong ating another formula para sa average velocity. So ipang-paslak nato na sa dire. Okay? So ipaslak nato na sa dire or i-substitute nato dira. So meron tayong formula para sa displacement or yung ating position or final position na 1/2 V sub O or ating initial velocity plus final velocity times time plus initial position. Okay? So next is yung ating velocity. So we have here yung ating formula para sa from acceleration. So ating formula is acceleration equals to the delta V over delta T. So meron tayong from here, magiging ganito ang ating formula. So ito lang siya, gilipat lang natin sa dito. Okay. So V sub final minus initial velocity is equals to acceleration times time. Okay. So yung V natin, kukunin natin yung final velocity. So yung formula natin is acceleration times time plus yung initial velocity. So ito yung ating velocity with respect na mayroon tayong data from acceleration. Okay? And then ito ang gagamitin natin naman pag hanapin yung final position and then given yung ating velocity, final and initial velocity, and then may time tayo, and then may initial position. So ito yung ating formula para makuha ang final position. And then equation, again, ito for the one-dimensional motion. So from kanina na final velocity na equals to acceleration times time plus initial velocity, i-equate natin siya doon sa another, equate natin siya dito sa final velocity, initial velocity plus final velocity is equals to acceleration times time plus 2 times initial velocity. So from there, meron tayong magiging final initial velocity plus final velocity over 2. Kumbaga, isa tong yung ating average speed, average velocity is equals to 1/2 AT plus VO. So ito siya. So V lang natin. So ang V natin is ito. So ito na. So divide 1/2. Divide 2. So yung ating average velocity is equals to 1/2 acceleration times time plus initial velocity. So from here, makukuha natin yung ating X, yung ating final position. So meron tayong average velocity times time plus initial position. So from there, ito siya, i-substitute itong value na to. So meron tayong final position na 1/2 acceleration times time plus initial velocity times time plus yung ating initial position. So ito siya galing. Okay? So from that, gipang ano lang ito, gipang distribute itong T natin. So magiging ma-simplify yung ating formula para sa final position na 1/2 AT squared plus V sub OT plus X sub O. So yung ating V sub O, initial velocity, X sub O is initial position. And then, continuation ng ating equation. So, V is equals to AT plus V sub O. And then yung time natin is equals to V minus V sub O over A. So, kumbaga, nag-exchange lang ito sila. Diba kanina, itong A nandito. Itong T na to, delta T ito siya ha. Pero since assumption natin, yung delta T is equals to T na. Since yung ating T sub 1 is equals to 0. Okay? So another one, yung sorry. So ang ating average velocity is i-plus yun ang ating velocity, dalawang velocity, initial at saka final, and then over 2. So another formula para sa average. So ipang ano lang natin siya, i-combine. So meron tayong distance, final distance or final position na average velocity or V bar times T plus X sub O or yung initial position. So from that, ito na siya. So ma-simplify, dito na tayo mag-diretsyo. So V sub squared is equals to V squared, o kumbaga initial velocity squared plus 2 times acceleration times, open parentheses ha, open parentheses, final position minus initial position. Okay. So last is ating summary of equation. So para sa final position, meron tayong average velocity times time plus initial position. And then para sa average velocity, so i-plus natin yung dalawang velocity natin from initial and final, and then i-divide natin sa 2. And then yung ating velocity is equals to acceleration times time plus initial velocity. And then yung ating another formula para sa final position is 1/2 AT squared plus V sub OT plus X sub O. And then yung ating velocity, another formula sa velocity. So velocity squared is equals to initial velocity squared plus 2A over open parentheses, final position minus initial position. Okay. So meron tayo ditong sample problem na. Tatakal na tayo ng ating mga sample problem. So for problem number 1, a plane starting from rest accelerates to 40 meters per second in 10 seconds. How far did the plane travel during this time? So write down natin yung mga data na nandun sa ating problem. So meron tayong velocity na final velocity na 40 meters per second. And then meron tayong time na 10 seconds or kumbaga yung ating final time from 0 to 10 seconds. So T final is 10 seconds. And then yung ating initial velocity is 0. Bakit? Again, at rest. Dahil sa word na at rest. So from at rest to final velocity na 40 meters per second. And then yung X sub 0 natin, since at rest siya, wala siyang gitravel na distance, so X sub 0 or initial velocity, initial position natin is 0. So hanapin natin yung final position niya. So, meron tayo dito initial average velocity. So i-add natin yung ating mga velocity. So 40 meter per second plus 0 meter per second over 2. So meron tayong 20 meter per second. And then yung ating formula para sa final position, again, balik tayo dun sa ating summary of equation. Itong ating gagamitin since given ng ating initial position, given ng ating time, and then given or nakuha natin ang ating average velocity. So, ipang-substitute na natin yung mga values natin. So, meron tayong average velocity na 20 meter per second. Yung time natin na 10 seconds, and then yung initial position is 0. So, meron tayong final position na 200 meters. So, okay. So, next problem. To avoid an accident, a car decelerates at 0.5 meter per second squared for 3.0 seconds and covers 15 meters of road. What was the car's initial velocity? So first, ipang-write down natin ang ating mga data. So meron tayong acceleration na negative 0.5 meter per second squared. Bakit siya negative? Dahil sa word na decelerates. So, negative ang ating value para sa acceleration. And then yung time natin given na 3.0 second. And then yung x natin, yung final final position niya na cover. Yung na-cover niya is 15 meters of the road. And then yung initial position is equals to 0. And then ano ang ating initial velocity? So ang gagamitin natin dito is itong formula ng ating final distance with a variable ng acceleration. Since sa data natin, meron tayong acceleration. Meron tayong value ng ating time, and then may value ang ating initial position. Okay. So, ipang-substitute yung mga value na nakuha natin sa problem, yung mga data na nasa problem. So, meron tayong final position na 15 meters is equals to 1/2 yung ating acceleration, negative 0.5, ang ating time na 3 seconds, tapos squared, plus yung VO, di ba ang hinahanap? So, variable siya. So, V sub O times 3 seconds, plus yung initial position na 0. So, ito na yung ating equation. So, isa lang yung ating unknown variable, pwede na natin ito siya i-shift solve sa calculator. So, pagka-shift solve niyo sa calculator, input yung mga value, shift solve, may value na lalabas na 5.75 meter per second para sa initial velocity. Okay? So, next, meron tayo dito problem number 3 na. So, a cheetah is walking at 1.0 meter per second. When it sees a zebra 25 meters away, what acceleration would be required to reach 20 meter per second in that distance? So, meron tayong, So, i-write down natin again yung ating mga data from the problem. So, meron tayong i-require na final velocity na 20 meter per second. So, ito na ang ating final velocity. And then, yung initial velocity natin is given at 1.0 meter per second. And then, yung ating distance, final distance na dapat ma-travel para makuha niya yung or mahabol niya yung zebra is 25 meters away, di ba? So, yung initial position niya is 0. Ano yung kanyang acceleration? So, what acceleration would be required to reach the 20.0 meter per second? So, yung formula na gagamitin natin is yung v squared equals to initial velocity squared plus 2 times acceleration, open parenthesis, final position minus initial position. So, yung ating velocity, final velocity is 20 meter per second times, and then squared is equals to initial velocity na 1.0 and then squared plus 2a. Ang ating variable, di ba? Acceleration. So, 2a. And then, yung ating final position dapat 25, di ba? Okay? 25 minus 0 from the initial position na 0. So, with this, meron na tayong equation. So, isa lang again yung ating unknown variable. Again, pwede na ito ma-input sa calculator. Shift solve na agad. So, malalabas sa inyong calculator ang value ng acceleration na 7.98 meter per second squared. Okay? So, next problem tayo. Problem number 4. So, the left ventricle of the heart accelerates blood from rest to a velocity of positive 26 centimeter per second. If the displacement of the blood during the acceleration is positive 2.0 centimeter, what determine its acceleration in centimeter per second squared? And then B, how much time does blood take to reach its final velocity, which is yung 26 centimeter per second. So again, i-write down natin yung ating mga data. So, meron tayong initial velocity na 0 dahil at rest, di ba? So, initial velocity 0. Final velocity 26.0 centimeter per second. And then yung ating delta x or displacement, nasabi naman dito na 2 centimeter. So, what is our acceleration? So, gagamitin natin na formula is yung ating velocity. Velocity squared equals to initial velocity squared plus 2a times final position minus initial position. So, ipang-substitute natin yung mga values natin na nakuha or yung mga data natin na nakuha sa ating problem. So, yung ating acceleration is 169 centimeter per second squared. Okay? So, yung ating, again ha, ipang-paslak na, hindi ko na siya input pa dito kasi pare-parehas naman din siya sa previous problem natin. So, yung final velocity is ito. So, input dyan. Initial velocity, input dito. And then, variable ito siya. And then, ito siya, input na dito. So, ito siya magiging delta x na to agad. So, 2 centimeter. Okay. So, acceleration, meron tayong 169 centimeter per second squared. And then, letter B, how much time does the blood take to reach its final velocity? So, again, meron tayong itong data dito. Okay? So, initial velocity 0, final velocity na 26 centimeter per second. And then, yung delta x natin or displacement na 2 centimeter. What is the time? Time ang hinahanap. So, ang formula na gagamitin natin is yung x is equals to average velocity plus times time plus initial position. And then yung average velocity natin again, i-plus natin yung ating mga velocity. So, initial velocity plus final velocity over 2. Okay, so mayroon tayong 26 over 2 is 13. So, siya, 13 cm per second. Okay? So, since ang ating initial velocity is 0, or pwede natin siya i-ganito na. V bar, wait lang. Bakit? Ilipat lang natin ito dito. So, x minus x sub o. So, delta x na. So, yung V bar natin is 13, di ba? 13t equals to 2 cm. So, meron tayong t na 2 over 13 or time na 0.15 seconds. Okay? The next problem. Wait lang. So, hindi ko na itatakal itong continuation. Natapos naman ating problem dito. Ay, another set of, ano ito siya? Another set of, hindi, ano lang, detailed solution niya lang ng ating number 4. Nalito din ako. So, sa number 5 tayo. So, problem number 5. Ito na ang ating last na for this topic. And then, next topic na tayo. Okay. Pero, the end of the video, nandito yung assignment. So, please, tapusin nyo ang video para makita ninyo ang inyong assignment. Okay, for problem number 5, the position of a particle is given by x is equals to negative 4t plus 2t squared. Then find the instantaneous velocity at A, 2.5 seconds, B, 4 seconds, at saka C na 10 seconds. So, solution natin. Ano yan? So, nasira ang aking slide. Ayaw niyang mag-move. Okay. So, dito na magtatapos ang ating video presentation class, ha? So, ipapakita ako na agad yung ating assignment. And then, itong ating slide, PowerPoint, is isa-send ko din sa inyo para mas ma-review nyo na maayos. And then, makinig kayo sa ating presentation para doon sa video para sa explanation naman. Kung hindi nyo maintindihan ang ating PowerPoint. So, okay, hindi nagagana ang aking slide dito. So, i-direct ko na kayo sa ating assignment. So, assignment number 1. Ako, hindi ko magpakita. So, assignment number 1, meron itong words. Hindi magpakita ang words. Hindi ko alam kung bakit hindi maggana ang aking slide. So, itong assignment number 1. Number 2. Oh, so, suppose that x velocity of the car A anytime t is given by the equation v sub x equals to 60 meter per second plus 0.5 meter per second squared times t squared. So, meron tayong mga hahanapin A, B, C, D. And then, assignment number 3, a motorist traveling a constant 15 meter per second, about 34 miles per hour, passes a school crossing where the speed limit is 10 meter per second or about 22 miles per hour. Just as the motorist passes the school crossing line, a police officer on a motorcycle stopped there and start in pursuit. So, naghahabulin nyo itong motorist na to with a constant acceleration of 3.0 meter per second squared. So, meron tayong hanapin na A and B. Okay, so dito nagtatapos ang ating video. So, next topic is yung falling object. So, next video na yun siya. Okay, class, thank you. So, see you next video presentation.